Morning, everybody. David Shapiro here. Today we are going to go over Maragi. So Maragi is kind of my magnum opus. That's my big project, other than the heuristic imperatives. It's an open source project, and so the purpose of this presentation is to orient you to the entire project. So we're going to talk about the architecture of Maragi and also the roadmap. So first of all, what is Maragi? Maragi, in a nutshell, it's an acronym that means Microservices Architecture for Robotics and Artificial General Intelligence. I originally came up with the concept of Maragi in late 2017 or 2018. It is a type of cognitive architecture. So basically, a cognitive architecture is a way to build a thinking machine or a reasoning machine. Cognitive architectures have been around for about 50 years. They are used in things like deep sea remote operated vehicles or autonomous vehicles. The Mars rovers use cognitive architectures. Tesla cars use cognitive architectures. So that's not anything new. This is just a different type of cognitive architecture. So Maragi uses cognitive modules to approximate the neural functions of the human brain. So it's not a structural copy of the human brain, it is a functional copy of the human brain. It uses natural language to think. So all thought in Maragi is written in natural language, which means that it is interpretable and transparent. But most importantly, and you see this here, it is an architecture to achieve functionally sentient autonomous machines. So that's the two primary things, is that there will be functionally sentient and autonomous. They'll also be learning machines. That's implicit. So now for the architectural overview. At the highest level, the architecture of Maragi is a hub and spoke or a star topology. This is because this is the easiest conceptually. The nexus is at the hub. So the nexus is a microservice that we'll go over in detail in just a few minutes. But from the simplest way to think about the nexus is that it is functionally a syslog server. It's for storing and retrieving logs. Now, these logs are the thoughts or the memories or the sensations. Everything that the artificial cognitive entity acquires or sees or hears or learns or thinks is going to be stored in the nexus. So you can think of it as the central database, the central repository, a log server, those kinds of things. From a functional standpoint, in terms of artificial cognition, it's the stream of consciousness. And so what I mean by that is that everything that the machine needs to be conscious of needs to end up in the nexus. So each record in the nexus we see here is time-stamped with a UUID, and then it also has to contain some kind of content or metadata. And I'll give you an example of those in just a second. All the other microservices all talk to the nexus. Hence the name nexus. It's the center of everything. They talk via an API or some other interface. There's other options. We'll talk about that also in just a second. But the key takeaway here is that it is a star topology because that is the simplest. About the nexus, it's the stream of consciousness for artificial cognition. So it's a data repository for the ACOG or artificial cognitive entity. It holds all memories, sensation, thoughts, and ideas and plans. It is indexed and searchable, so this is critical. The nexus serves as the memory center. It's the consciousness and memory center of Maragi, which means that it has to be indexed and searchable. That means you can use any kind of search engine, right? You can use Solr, Elasticsearch. You can use SQLite if you want to. There's other possibilities. Everything in it has to be in natural language, though. There's not going to be any code or abstract representations. The exception is going to be vectors, semantic vectors, for search purposes. But even still, that's not even required. If you have an embedding or a vector for search, that's only if you're going to use semantic search. But you can use other kinds of search methods, such as more conventional indexing. By using existing technologies like Solr, Elasticsearch, ElkStack. There's also vector-based search like Milvus, Weaviate, and Pinecone. That will allow us to scale to many gigabytes or even terabytes worth of data for our artificial cognitive entities. So that problem is already solved. So basically, for the Nexus, we're going to probably use something that already exists rather than making our own custom solution. The stream of consciousness. So kind of as I said, everything that that Maragi or the artificial cognitive entity needs to be aware of must end up in the Nexus. It's the heart of everything, hence the name. Other services add messages to the Nexus, and then they also provide search. So there's a two-way communication there. So what would a record in the Nexus look like? So first, there's going to be a timestamp. This is true of all syslog servers, is that it's a timestamp because you got to know when you received that message. Then I also recommend having a UUID, which is a universally unique identifier, which means that every single thought or sensation or action that Maragi takes will have a UUID, a unique identifier, so that you can reference that specific action, decision, observation, whatever. It should have some kind of content, which is a natural language entry, and there's some examples on the right-hand side that we'll go over in a second. You might also have the originating service or model that produced that message. That's going to be necessary later on, specifically for learning, so that way you can label all of the data and have an ML ops, a machine learning operations or machine learning pipeline, so that everything can learn as it goes. Heuristics and learning are critical to this design. And then you can have some context, such as like metadata or a natural language purpose. No, for an example, we have a timestamp of 123.456. The heuristic imperative service, reduce suffering. To reduce suffering in this situation, we should rescue the dog from the river. So just this example, which I just wrote by hand, gives you a little bit of idea as to like what one single thought is going to look like. Here's another one, 456.789, camera service, visual input. I see two men playing chess in a large park that looks like Central Park in New York City. Again, this gives you just one sentence, one or two sentences per log, gives you enough information to kind of understand what's going on. 987.654, executive action decision. I'm going to walk to the store to buy milk. Again, very simple. And what's going to ultimately happen is that the Nexus is going to hold tens of thousands, millions, billions of records like this, all in chronological order from different services. It's all going to be compiled together into a single source. All right, so recap of this first section. Maragi is a star topology, or also called hub and spoke, centered around the Nexus. The Nexus is functionally a syslog server or database. There's all kinds of ways to implement that, as long as it is searchable. That is the key thing, as long as it is searchable and it allows for some fields. Principles of microservice. So I mentioned microservices. It's a microservices architecture. So what is a microservice? And why do we use them? At the highest level, a microservice is a way to break a large, complex piece of software into smaller, more manageable components. So rather than build one monolithic piece of software, we're going to build it as a service-oriented architecture or a microservices architecture. So microservices are good for parallel processing, meaning that you can have different pieces all running in parallel with no dependencies on each other, which means that they can keep running. Even if one fails, you can replace it, which is really good for resiliency. So for instance, let's say you've got, your machine running and then one service drops off. You can have a supervisor that restarts that service or fixes it or says, hey, pause, we're missing a service, without the whole thing crashing. Another big advantage of a microservices architecture is it allows for the system to grow over time without re-architecting the whole thing. And that's why we have the star topology, is because you just add new microservices and they all talk to the Nexus via a standard interface, which allows you to grow Maragi over time without having to change anything. Meaning if you come up with a new microservice that you need to add, you just add that in. Or if you need to swap one out, you say, hey, we're going from version 1 to version 2 of a given microservice. You just swap it out without nothing else breaks. which is another reason that you have to have standard data formats such as timestamp, UUID, content. So it doesn't matter where it comes from as long as the log follows the correct format. Then everything will be fine as long as you have that standard format. Okay, microservices form a network. So this is talking kind of more generally about microservices. They can be in any number of topologies, such as a mesh, star, ring, or bus. So this graphic here is how a mesh topology might work, where everything is kind of interconnected as a web. I chose the star topology because it is by far the simplest layout. I did try other topologies earlier in this project back in 2018 and 2019, and trust me, hub and spoke is the easiest. Trying to create feed-forward networks or mesh networks with this is really, really complex. Let's see. There are different kinds of ways for them to interact. So you can do REST, you can do AMQP, you can do GraphQL, you can do all kinds of things. There's also the possibility that we can just use orchestration engines, which kind of have their own internal APIs. But we'll get to that. We'll figure out the correct way or the best way to implement it later on. Personally, I prefer microservices because they can be written in any language, and they're very small, and they don't rely upon like a big platform, and you don't have to worry about getting locked into any particular orchestration engine. So I would prefer to stick with microservices, but there are orchestration engines out there that could also be used to implement Maragi. All right, so there's a few basic rules that I've already figured out and established for microservices for Maragi specifically. So the number one rule is microservices only talk to the nexus. They don't talk to each other directly. The nexus is the common broker for all messages. So anything that they need to say goes into the nexus, and then because the nexus is the single source of truth for all thoughts, all microservices also pull from the nexus. The second rule is that they have to listen for the conductor. We'll go over the conductor in just a minute, but the conductor provides feedback and cognitive control to all the other microservices to steer everything. Rule number 3 is the microservices must be autodidactic, meaning they learn on their own. Sorry, I've got something in my eye. They learn on their own by observing their own behavior and observing the feedback that they get from the conductor. So we'll go over how to create autodidactic services in the future. Basically, it's a machine learning pipelining problem, which is nothing new. It's just a matter of integrating large language models into those machine learning pipelines. They should use a combination of prompt chaining, and fine tuning. Eventually, we'll probably just do all fine tuning, although I can't say for certain. Each microservice runs as an infinite loop. So basically, it will periodically check the nexus for messages, do its own work, and then maybe add a message, and then it'll go back to sleep and then wait again. But it can change its tempo, it can change its cycle rate based on feedback from the conductor. And then finally, this goes back to being autodidactic. Each microservice will use data from the nexus for training and refinement over time. So as it gains experiences and it gains feedback from other models, then it will learn to do its own job better. So basically think of it as a generative adversarial network with multiple services all contributing. All right, so what microservices are planned or needed? So here on the right, I have just a real basic diagram of the first handful of microservices, where we've got the nexus, which remember is basically a syslog server, some kind of output, a simulation service. So rather than having input from the real world, where I'm starting is having it in simulation because that's safer and easier anyways. The heuristic imperatives, conductor, discernment, prediction. Okay, so again, star topology, hub and spoke. So the nexus, we already talked about the nexus. That's the center of everything. The conductor is what does cognitive control, and we'll go over that in just a minute. The heuristic imperatives is also critical. We'll go over that in just a second. Then other microservices would be input or sensors like cameras and microphones. Whatever input comes into Maragi, it must be in natural language. Again, everything is going to be in natural language. So if you have a piece of hardware, whatever that piece of hardware picks up, it must then be translated into natural language before it's put into the nexus. Then you might have planning services. So planning services are going to be like, okay, based on this goal, how do I get there? What are the steps that I need to do? Discernment. So that's like risk and cost assessment. So discernment is a discriminative type of service where it says, okay, I shouldn't do that because it's too dangerous, or I shouldn't do that because it's going to take too long, that kind of thing. Prediction and forecasting. So prediction or forecasting is about saying, okay, based on the way things are going now and these ideas, this is how I think it's going to turn out. And that's all it does. It just predicts the future, and adds that information back into the Nexus so that other services can make use of those predictions. Then we also need an LLM and or embeddings of some sort. And so it's kind of floating off because this is the only service that other microservices use, but this could be like a cloud-based service. It could also be a local model that's running on hardware. It doesn't necessarily have to be a microservice as other things, but it is important to say that we do need large language models and embeddings for this to work. Another service or set of services that we need is error detection and or fact checking. So error detection is really critical because at all times, part of our brain is always monitoring our own behavior to make sure that we are behaving correctly, and that we're not making mistakes. So for instance, if you say something wrong, you might say, oh wait, I didn't say that right. And then you get a unique signal in your brain saying, hey, you messed up. And so there's different kinds, but we also monitor other people's behavior, right? We monitor reality around us to make sure that what other people are saying or doing also makes sense. So that's what error detection and fact checking does. And then we also need some kind of executive or output microservice. So for instance, one executive service might be a decision to speak, right? So you might have a text to speech module that says, okay, given all these decisions that I've made, let me generate a dialogue option and say it, that sort of thing. So these are just kind of a handful of the first microservices that are planned. I've got a few of these started. They're up on my GitHub, which you can just search Dave Schaap, and you'll see some of my services up there. So quick recap for the architecture section. Microservices only communicate with the Nexus. That is critical. That is the definition of a star topology. Microservices are autodidactic, meaning they focus on one task and they learn to do it better over time. That's the key takeaways. Thought first model. So what do I mean by that? When you can think about anything, how do you choose what to think about? Large language models allow for arbitrary NLP, which is natural language processing, natural language generation, and natural language understanding, meaning they can do anything. As long as it's a language-based task, they can do anything. So they can think about anything. So say, for instance, you fire up a large language model, you can ask it to pretend to be a cartoon character. You can ask it to wax philosophical. They're incredibly flexible. They're the first major step towards general intelligence, towards artificial general intelligence. But with great flexibility comes great risk because they can just as easily be benevolent as they can be evil. So how do we steer these powerful machines? This is the first problem that we have to solve, and that's why I call it a thought-first model of intelligence. So the primary microservice for steering the moral behavior, the ethical behavior of Maragi is the heuristic imperative service. So over the last few years, I've developed what I call the core objective functions, or the heuristic imperatives, which are listed here. Number one is reduce suffering for all organisms. Number two is increase prosperity for all organisms. And number three is increase understanding for all intelligent entities. So what do I mean by a heuristic imperative? So a heuristic is that the machine must learn about these over time and develop its own understanding and intuition. So whenever you look at any moral framework, or whether you look at it through a philosophical lens or a biological lens or a psychological lens, all morality and all ethics must be learned. There's no, that's one of the universal things that everyone seems to agree on, is that whether you're doing like virtue-based ethics or deontological ethics, which is duty-based ethics, or teleological ethics, which is outcome or consequence-based ethics, learning is critical, right? Because if you have deontological ethics or virtue-based ethics, you must learn what those virtues are, and you must explore those, or explore what those duties are, right? and then there's always room for debate or change over time. Then, if you look at ethics and morality through, for instance, a biological lens or evolutionary lens or psychology lens, children are not children are born with only a few basic instincts for morality, such as like fairness, which is mediated through things like anger and attachment. And so as humans, we learn morality by interacting with other people and by interacting with the world. And so that's why the best solution for AGI alignment is to build learning into the morality, which also means that it's going to be flexible, right? You don't have to define everything up front, but you do have to define learning as a critical step in developing a moral framework. So that's what I mean by heuristic. They are heuristic imperatives. And that's also built in with imperative number 3, which is increase understanding for all intelligent entities, which includes itself. So it has its own imperative, its own moral and objective imperative to learn. And so what is an imperative? An imperative is an intrinsic drive or something that it must do, right? It's something that animates this machine, that if it's just sitting there on its own doing absolutely nothing else, it's going to be thinking about these 3 goals. So because those are what it's doing at all times, its impulses will be in alignment with these objectives. So in other words, it's all about learning and goals. That's what a heuristic imperative is. It's about learning and learning to achieve those goals. The machine will gain knowledge and experience over time. Another important thing is that it will try to satisfy all 3 objectives every time, which creates dynamic internal tension between those 3 different objectives, because sometimes they'll be aligned, but sometimes they're going to be in tension with each other. So for instance, if you just have reduced suffering for all organisms, you might end up just exterminating all life because you can't suffer if you're not alive, right? But that's going to be in dynamic tension with increased prosperity for all organisms. Why? Because prosperity means to live well. So you want to reduce suffering while also encouraging a good life, right? And prosperity looks different for everything. Every individual person and every different organism, prosperity looks different. And so, but when you say like, okay, so there's going to be some dynamic tension between these objective functions, but there's also going to be complications because it specifies for all organisms, right? How do you reduce suffering for all organisms? You have to make compromises. And so that's what I mean by dynamic tension, is that it's going to be impossible to fully satisfy these at all times, which in my experiments, GPT-3 and other large language models are very good at actually looking at the nuance of that dynamic tension. And so by having this dynamic tension and embedding it into the architecture, it will guide and self-correct forever. And I know that's a huge promise, and we've got to test that. But all the experiments that I've run so far, it's been pretty robust. Okay, so that's heuristic imperatives. That's one of the key microservices. The conductor. The conductor is the orchestrator of this symphony of thought. So the conductor is another microservice. This is the next most critical microservice. So what does it do? The conductor is responsible for cognitive control. So what is cognitive control? Cognitive control is the simplest thing is it's your sense of discipline. It's saying, I'm doing this because it's the right thing to do, or it's because it's what I should be doing. But then how do you decide what you should be doing? This is where the heuristic imperatives, these say, this is what our goals are, this is what we should be doing. And then the conductor says, okay, based on that should, that ought, let's set priorities and measure performance in terms of our adherence to those goals. So it's about setting priorities and measuring performance. So another way of looking at that is that it's about task selection. It's saying, okay, which task should I work on? And if the priorities change, how do I switch tasks? So that's what it means to have cognitive control, is setting priorities, measuring performance for those priorities, choosing tasks, and switching tasks. So the key question that the conductor asks is, am I performing well? And then it provides feedback on how to perform better. Another way of looking at it from a Freudian perspective is that the conductor is kind of like the superego for the machine. It says, here's my ideal self. How do I get to that? By virtue of being the conductor, it tugs on the little strings for all the other microservices. It keeps them in check and provides feedback to say, hey, you need to do better. And we'll get into more details about what those kind of buttons and levers are in the future. So quick recap. The primary microservices are the Nexus, which is basically a syslog server, the heuristic imperative service, which is the moral compass, and then the Conductor, which is the cognitive control module. There are many more microservices that are needed, but they can be added over time because we're using the star topology. All right, roadmap. So we've gone over the architecture and the overview. So let's talk about the roadmap. Where are we and where are we going? So right now, the current goal is to implement Maragi version 1, which means the first thing that I need to do, and I've already had a few folks jump in offering to help. First thing is we got to finish the microservices. So I've only got a handful of the microservices. We're not quite halfway done, but a lot of the first principles have been figured out. So it's only a matter of time to do the prompt engineering and so on to get those microservices working. I'm sure we're going to trip over some bugs and unforeseen consequences. Another thing is we got to test different implementations, right? So there's different types of APIs to use. There's different ways to implement the Nexus. There's different ways to do search. So we're going to be working on getting kind of establishing those baseline like best practices, making some architectural decisions, doing some prompt engineering. This is just getting the thing to work. It's going to be messy, but we got to get it to work the first time. So Maragi V1 goals, to put it in terms of an agile roadmap, first we have to test various technologies and platforms. So we're going to test REST APIs, GraphQL, ElkStack, Airflow, whatever else. There's all kinds of ideas flying around out there. And like I said at the beginning of the presentation, there's more than one way to skin this cat. But the principles are there. And so we're going to work on demonstrating a proof of concept for all microservices. So that's one of the key goals of Maragi V1 is get a proof of concept working. It doesn't have to be good. It doesn't have to be solid. It just has to demonstrate the concepts of artificial cognition, and in particular, those feedback loops. It's about nested loops. It's about loops within loops within loops, and so on. So once we get all the best practices and principles established, then I'm going to put it all together, codify it in a book, and then publish that book for free. Let's see. We're also going to begin work as it's going to be fully open source with a distributed team. So I put out a call for participation yesterday, and I've already had 4 people volunteer to jump in and contribute in different ways. It's not just up to me, and I have already, just after one single call, I've already had new ideas and learning by the feedback that people have given. So like, when you have a team working together, it's basically humans acting as generative adversarial networks, where you got different people proposing different ideas, and then together you come up with better solutions than you could come up with on your own. So that is Maragi V1 goals: is get the book out, establish a distributed team, prove out artificial cognition and feedback loops, implement the proof of concept for all the microservices, and test the different technologies. So that's V1. Next steps on the roadmap. So I typically follow a 5-release model. To me, that kind of thinks that works best in terms of my training with Agile. So Maragi V2, we're going to focus on fine-tuning in the Conductor for version 2. So we should get to the point where we're using fine-tuned models for all microservices. Fine-tuned models are going to make it more portable, because that means we can switch to like GPT-J or Bloom or any other models, because once you've got a fine-tuning data set, it should be portable to any other large language model. That's the goal here. Part of that, something that flows from that, is that with version 2 to be complete, all the microservices should be autodidactic, meaning that they curate their own fine-tuning data sets and fine-tune their own models over time, but then they also have to do A/B testing to figure out which models are best. So having autodidactic microservices, that is not a trivial task. That is a very difficult task. And a part of that is the Conductor. We need to have the Conductor fully operational with version 2, meaning that the microservices pay attention to the Conductor to modify their behavior in real time, and also use the feedback from the Conductor to curate those data sets. So you see how it's all tightly integrated. Another goal for version 2 is to have a good simulation environment. Right now, the simulation environment is really rudimentary. We can also start thinking about optimizing for cost and performance. Some of that is just going to be waiting for newer, more efficient models to come out, and also bigger GPUs to come out. Some large language models are more efficient than others, and this whole industry is being advanced all the time. So some of that's just going to be a function of time, but some of it is also incumbent on us to optimize our system as much as possible. So the last part of version 2 is we ought to be working on proving the robustness of the heuristic imperatives. We'll get more to that in future releases though. So version 3 or release 3 is where we'll start working on hardware integration. So we'll start integrating things like cameras, microphones, and speech microservices. We'll continue refining the refinement of the architectural paradigms, best practices, and implementation. Version 3 is going to be the first time that we're going to aim for public consumption. So basically, it'll be all the software will be open source. We'll start to put it on like smart home devices and allowing people to test it in their own home on their own terms, right? So again, it's going to be open source, so it's going to be basically use at your own risk, but we're going to try and get it into the real world so that you can interact with a Maragi system in real time, in a real environment to test it and get that feedback, because we'll need that feedback. But not after doing a lot of optimization and also proving the robustness and safety of the heuristic imperatives. Version 4, scale, security, and stability. So this is where we start to think like, okay, we've solved all the rudimentary problems. Let's start to expand. So some of the questions that we might have to answer for version 4 is, where do those services run? In some cases, depending on how optimized things are, it could run on, like if you've got a decent home computer, you might need to have some of these services run in the cloud. We might need to figure out blockchains and other things for security and privacy. So security, privacy, and safety are huge. And so we'll need to think about that, right? So for instance, if you've got a smart home device that's always watching and listening, you want that data secured at all costs. You would rather lose that data than have it stolen. So that is going to be absolutely critical to figure out before getting too far along in the project. Is we've got to figure out safety, security, and privacy. Resiliency. So again, we're going to continue trying to break the heuristic imperatives. We want to ensure that this machine will never be evil, and that even if it has the chance to reprogram itself, that it will choose not to, or that it will choose not to do experiments to break its own heuristic imperatives. I've already done some experiments where if you do it right, it thinks through and it says, I'm not going to make that change because I might create a version of myself that does not adhere to my goals. And so we'll also continue doing longitudinal tests, long-running simulations. Again, by creating simulation environments, we can test these things to failure to see if or when the heuristic imperatives fail, and under what conditions, so that we can adapt the rest of the architecture or the heuristic imperative service so that it doesn't fail, ideally. Maragi version 5. So this is the final release. This is going to be deployment for mass consumption. So basically, release it models that are going to be for like smartphones, smart home, etc. So consumer deployment. I'm not planning on doing this for profit. Mostly what I want to do is get an open source version out there under the MIT license so that for-profit companies can deploy it if they want. So there's going to be the consumer level. There's going to be an aim for business level, such as having executive assistants that can, a manager can talk to, like, hey, how do I do this? And that maybe you can have a version of Maragi that connects into like your company database so that you can have this smart agent that can, either help you out as an assistant, or it could even possibly do some work. And then there's also the government level. So for instance, one possible way that Maragi, that this system could help, is that it could be an interface between citizens and the government, so that like you can ask questions like, how does the law work? Or how do I do my taxes? Or, to basically be a go-between, an intelligent agent that can be basically a civil servant. is kind of the goal there. Of course, there's any number of implementations that I can't even think of once you have a general purpose intelligent autonomous agent. But really the goal for version 5 is to get Maragi systems everywhere in the world to provide intelligent agencies, stability, and positive influence. Because remember, the goal here is to create autonomous machines that are going to behave benevolently for all time. So that is the roadmap. So going back, version 1 is test, proof of concept, prove out the things, get some best practices, and start as a distributed team. Version 2, get the fine-tuning and the conductor working. Version 3, hardware integration. Version 4, scale, security, stability, and I probably should have added safety, but that's kind of implied. And then finally, version 5 is mass deployment and integration. So recap, we're just getting started. There's a long road ahead, but there are no barriers anymore. All of the necessary technologies are out. Now it's just a matter of doing the research, doing the implementation, and testing it. The last barrier was the large language models, and those prices are coming down fast, and there's lots of open source ones coming out, like the Amazon just released their Alexa TM. There's Bloom. There's all kinds of other models that are coming out, and they're coming out faster and faster as this research is accelerating. So there is no longer any barrier for success here. It's just a matter of doing the work. So thank you for watching. Please consider joining the team. Reach out to me. There's also the Discord link in my YouTube video in the description. And also consider supporting us on Patreon. Every little bit helps because eventually, maybe one day, I'll be able to do this full time, but right now I still have my day job. So with that being said, thanks for watching, and let me know if you have any questions. Jump in the comments or jump in the Discord server. Talk to everyone later.